Hi there. Welcome to Tech Demystified, where we demystify tech and coding concepts that seem impossible until you realize just how simple they can be. Today, we're tackling a crucial topic: how passwords are kept safe. You've probably heard about passwords being hashed before, but what does that actually mean? How does it protect your information? By the end of this video, you'll understand exactly how passwords are kept safe, how hashing works, and learn how to hash passwords yourself using Python. Let's dive in. Whenever you create an account online, you're asked to set a password. But companies don't just store your password as plain text. At least, they shouldn't. Instead, they use a technique called hashing to secure it. What is hashing? Hashing is the process of converting your password into a fixed-length string of characters using a special algorithm. For example, the password 1234 might become something like this. But here's the cool part. Hashing is one way. Once hashed, the original password can't be reversed or decoded. The same password always produces the same hash. Even a tiny change in the input drastically changes the hash. This is called the avalanche effect. This means that even if someone steals the stored hashes, they can't easily determine the original passwords. But this brings up an interesting question. If they only store your hash and they can't work out your password from the hash, how do they know that when you sign in with your password it is the correct password? Here's how. When you log in, the system doesn't need to know your original password. Instead, it hashes the password you just entered and compares it to the stored hash. If the two hashes match, the system knows you entered the correct password. The hashing algorithm ensures that the same input always produces the same output, making this comparison possible. But how can we do this ourselves? Let's jump into VS Code and see this in action. To hash passwords in Python, we'll use the bcrypt library, which is widely used for password hashing because it's secure and easy to implement. First, let's install the library. Now, let's dive into the code. Step 2. Before we hash a password, let's talk about an important concept: salt. A salt is a random string of data added to the password before it is hashed. Why is it necessary? Without a salt, two users with the same password would produce identical hashes, making it easier for attackers to identify common passwords using pre-computed hash databases, also called rainbow tables. The salt ensures that even if two users have the same password, their hashes will be unique. Now, let's hash a password. Here is the code used to hash and verify a password. Let's go through it. Importing bcrypt. The bcrypt library is imported to handle the hashing and verification process. It is known for its robust security features, including salting. Generating a salt. The gensalt function generates a unique, random salt for each password. This ensures that even if two passwords are identical, their hashes will differ. Hashing the password. The hashPW function takes the plaintext password and the generated salt, hashes them using the bcrypt algorithm, and outputs the hashed password. This hash is what is stored in a secure database. Verifying the password. The checkPW function hashes the user's input, entered during login, and compares it to the stored hash. If the two hashes match, the function returns true, indicating the password is correct. Output. The hashed password is displayed to demonstrate what gets stored securely. The verification process checks if the user input matches the stored hash, printing whether the login attempt is successful or not. Here's a breakdown and recap of what's happening. Salting. The salt adds randomness to the password, ensuring that even if two users have the same password, their hashes will be different. Hashing. The password plus salt is passed through the bcrypt algorithm to produce the hash. Verification. When verifying, the input password is salted and hashed again, and the result is compared to the stored hash. This ensures that even if someone gets hold of the hashed passwords, they can't easily figure out the original ones. And there you have it. In just a few lines of Python code, you've learned how to hash passwords and understand why this technique is essential for keeping our digital lives secure. Remember, always use hashing when storing passwords. Plaintext passwords are a big no-no. If you enjoyed this tutorial, be sure to like, subscribe, and comment below on what tech topic you'd like me to demystify next. Thanks for watching, and I'll see you in the next video.